everyone, welcome to our first ever modular community live stream. I'm your host Shashank. We're so excited to have you here. We'll wait for a couple more minutes as people join in. We're really excited to answer all your questions. Hopefully you see some familiar faces here on screen. And while we wait for folks to join in, let us know where you're joining in from. We're really excited to do this first live stream and hopefully many more in the future. Let us know where you're joining from, and if you have questions, this is really your live stream. We are here to answer your questions, so please put in your questions on the stream anytime during the live stream. I'll walk through the format in a moment, so please put in your question anytime during the live stream, and I'll pick. You won't be interrupting us even if we are talking. I'll pick them up. It's my job to interrupt and ask the questions. So please have your questions. Okay, we have folks joining in from India, Florida, exciting. Portugal, welcome. Washington, that's awesome. When is the release? That's not a place, but we will be answering those questions as well. Welcome. Norfolk, Ireland, that's so exciting. Well, I should mention I'm in California. Okay, I think here's what we'll do for the as far as the format is concerned. We'll do a quick round of introductions. Hopefully, you see some familiar faces. After a quick round of introductions, we have some news to share with you, some updates to Mojo, and some. I won't spoil anything here. So we have some news to share with you, and after that, we'll open up the floor for Q&A. We'll spend the rest of the live stream answering your questions. Please keep putting in your questions. Many of you who are part of our community on Discord have already submitted questions. We have those as well. We'll try to get to as many as possible. If we can't get to all of them, we'll do another live stream. We have others planned, and towards the end of the live stream, I'll share what we're planning to do in the future. Okay, with that, let's just start with a quick round of introductions. Again, I'm Shashank. I'm a developer advocate at Modular, and let's go alphabetic, I suppose. Abdul, you're muted, by the way.
Yeah, awesome. Hi, my name is Abdul. I'm a kernel manager here at Modular. I make things go fast. And I've used Mojo for the past 8 months. So,
Chris.
Hi, everyone. I'm Chris. I like building beautiful things. I help lead the team at Modular to help build Mojo, make AI better and safer and faster and more awesome for everyone. Happy to be here.
Wait, what comes for next? Jeff?
Hi, everyone. I'm Jeff. I'm super excited to see you all here today and answer any questions you have about Mojo. I'm here at Modular building the Mojo programming language. And it's super exciting, and it's exciting to see all these people using the language and looking forward to the release.
Awesome. Pramod?
Hey guys, very nice to see all of you here. So I'm part of the product management team here at Modular. So I'm super excited to be talking about Mojo and the programming model today.
Awesome. Before we jump in, on the comments, let us know if everything looks good, sounds good. Can you hear us? Can you see us? If everything looks good, we'll get started with the program we have planned for you today. All good? Okay, I don't see any complaints on the stream, so I'm assuming everything looks and sounds good. Awesome. Okay, thank you. One response is sufficient. All right, so let's start with our program today. So Pramod, Jeff, and Abdul are going to share some updates first, and feel free to ask your questions as they're doing that, as you enjoy the content. And also, after about 15 minutes of updates, we'll do Q&A. We're dedicating the rest of the live stream for Q&A. With that, Pramod, let's get started. What exciting things do you have for us here?
Okay, yeah. So we've been cooking, some things in our modular kitchen for the last few weeks, and I'm really excited to show you what we've been doing. So we are running. So you've all been able to access Mojo via the Mojo Playground. It's kind of a sandbox environment. You can only run, Jupyter, Python kind of notebooks. So we are going to bring Mojo to a computer near you. So I just wanted to talk about that today. It's currently in closed beta with a few people, and we're going to be releasing it to all of you guys very, very soon. So on the screen here, I have I've opened a Mojo program in my Visual Studio Code. So I'm looking at some matrix multiplication code. The interesting thing is that I'm connected to a system running a Mojo container. So I'm using the full power of Visual Studio Code. So you can see here we have syntax highlighting. We also have hover. It shows you the API and all the function definitions. We can also do code completion. So if I look at tensor shape, if I did a type, then it shows you all the APIs that are available in the tensor shape data type that Abdul will be talking about pretty soon. So this is all pretty exciting. I'm also able to open Mojo Notebook. So I have a Mojo Jupyter kernel. So let's probably change something here and try to run this particular cell, and you can see the cell is able to run Mojo code. I also have a terminal here. So we have released a GitHub repository that contains all of the Mojo notebooks and some sample Mojo programs to help you guys get started. So I'm going to try to run a hello Mojo code. You can see here that runs. Let's try to do some really simple Python interop, and you can see here it says hello from Python. I'm able to run import and create a NumPy array. So all of that code works. Mojo is able to interop with Python really well. So yeah, this is all going to come to a computer near you very, very soon. So I'm super excited. I hope you guys all try this out and give us feedback. Over back to you, Shashank.
Awesome. Thanks, Pramod. And I guess this is a question I expected, which was no download link for us today. Well, my answer to you is stay tuned. The best thing you can do right now is go to the website and sign up to be notified, and you will have access to all of this soon.
Shashank, can I be naughty?
Yes.
Can I go a little bit further? Can we say that we're pretty certain it's going to be out in 2 weeks? Maybe it'll be out next week. We'll see. But
maybe Chris is allowed to say that.
I know some people actually want to use this stuff, so we're working really hard.
Awesome. We actually have a closed beta going on too. We're very close. Yeah, we're excited to share this with you today. Any questions about what's coming up? I know we have a lot of other questions about Python interop and packet measure and all that. We'll get to all of that. So we're excited. Let's move on to the next topic, because I want to dedicate most of this stream to answering all these questions that are coming in. Next up is, who wants to go, Jeff or Abdul?
Well, I can talk quickly about
Awesome.
some of the stuff that we announced at launch. So a couple months back, we released Mojo to the world in the playground, and it was packed full of features, but not that many features. It was still a very young programming language, and we released a roadmap showing what we want Mojo to have in, say, a couple months in a year. And two of the most important things on that roadmap were traits and lifetimes. Traits means that you can write real generic algorithms and functions in Mojo, similar to languages like Swift that has protocols, traits, and Rust, or concepts in C++20. Lifetimes were something that we're building on the thought leadership that was pushed by Rust. Rust demonstrated that you can write memory-safe, fast code with static analysis and lifetime parameters. And in Mojo, we want to really, take that the next step and show that, yeah, you can write simple and fast, but it's also easy to use. And so lifetimes, in order to return references and ensure that you have exclusive ownership of objects, these are things that are going to be coming soon. They're cooking right now.
Awesome. Do you have a demo for us, Jeff? Or
Unfortunately, no.
Okay.
When we have more details on what these features are going to look like in the language, we absolutely are going to share them with the community.
Awesome. So as you all can see, Jeff has his ID handy. If you have questions and if there's stuff we can demo for you, we will. So keep asking your questions.
Hey, Jeff, I'll ask a question, because we get this very frequently, probably from the same person.
Sure.
Can Mojo be used for microcontrollers? Like,
Absolutely.
can you make a small binary? Like, how big is Hello World these days?
So Hello World is about 20 kilobytes. And in Mojo, as a language that was built to tackle some of the problems in AI, means that we need to solve deployability, we need to have self-contained applications, we need to have small binary sizes, because it turns out that deploying something on a GPU or on your custom, XPU hardware is the same faces the same challenges as deploying on a small microcontroller, where you're limited in binary size, where you don't want to have, you want a self-contained binary that doesn't have implicit dependencies. Or you don't want to carry a big runtime around. And so Mojo can produce very small, self-contained, statically linked binaries that you can deploy on, a Raspberry Pi, on an STM, on an Arduino, even if you really want to. And it turns out that this is the same way we're going to be able to get code to deploy so easily on GPUs and in other more exotic environments to take advantage of all the hardware that's out there.
Yeah, and that's a statically linked binary.
Correct.
All the
statically linked. No implicit dependencies. No.
Well, except for kernel, right? So the kernel has to do I/O.
Yes.
That's awesome. In fact, you answered some of the questions that were coming in about what type of binary it is and all that. So that's awesome. If you have follow-up questions, I guess please share in the comments. We'll get all of this. And let's go through our second topic, Abdul, and then we'll spend the rest of the time with these questions. And on to you. I have a screen open, Abdul.
Right. So as Jeff was mentioning, there was a lot of changes in the prior 2 weeks, and there's going to be a lot of release, changes coming to the SDK. I want to kind of, detail a few of them. That this is not inclusive. There's a lot of things that is user visible. There's a lot more that's like non-user visible that increase optimization. A lot of things related to tooling, etc. One thing that's kind of user visible is we reorganized the standard library based on like the progress that we made on packaging and so on. We were able to kind of develop more of the Python style packages, which allows us to move things and reorganize things. And that's like very important because when we release, that's, we can more, and we're kind of breaking stuff, but it's better to break stuff in the playground than on your machine. So for example, rather than saying, from capital M math import square root, some of these are just like, capitalization changes, but you can say from math import square root, and that kind of matches more of the Python style programming. You can have global aliases. This has been around for a while, but you can have global aliases. The other thing that, and by the way, this example is going to be part of the SDK, so you don't have to like screenshot it or anything like that. We have a new keyword called unroll, and that allows you to perform unrolling of a loop and kind of decrease the overhead of loop operations. I think we're going to write a blog post about what unroll means, since there was one of the questions on the discourse, and the GitHub asked what this unroll feature means. We could write a blog post. And yeah, in general, it's like more and more the language becomes, you're getting the performance, but you're also getting the familiarity with Python. So this looks exactly like Python, and you're getting huge speed ups over the Python implementation. This implementation is actually comparable in terms of speed, is comparable to the C++ implementation. And this is actually a benchmark, a common benchmark across programming languages. So that's why we picked this example. Yeah, that's more or less it for me. If you have any questions, please ask them.
I saw a couple people.
Shashank, I think you're muted, dude.
There it is. Thank you for catching that. I was not miming. I was, as I was mentioning, the code example that Abdul's showing and many more are on GitHub. We recently pushed them to public, so you can go, I shared the link earlier. Head over there. You won't be able to run them, of course, today, but very soon, very soon. And yeah, we look forward to your feedback too as you use Mojo and run those examples in the future. So there are, I guess, a couple of questions coming in. Now might be a good time to pivot to going through the questions that we have from Discord and also from the questions that are coming in. So let's start with sort of the basics, which is about Mojo availability. We already briefly discussed when Mojo SDK will be released. And here's a question about the language. And the question is, what areas would you say Mojo is designed for, and what areas would you say Mojo is possibly not a great fit for? I guess a little bit philosophical, but who wants to take this?
Well, Mojo, we are building Mojo to tackle a lot of the hard problems in AI. But Mojo itself is a general purpose programming language like C, C++, Python, and all the other mainstay languages out there. So the applications of Mojo right now are limited by what kind of libraries have been built for it. We have, kernel libraries. We have a tensor type, a buffer type, a SIMD type, and these aspects of the library are heavily targeted towards writing high performance kernels, as well as AI applications like being able to build small binaries. But because Mojo is a general purpose programming language, we can write a web server in Mojo. You can write a framework for a GUI for building GUIs in Mojo. We don't have them because Modular is focusing on solving the challenges in ML infrastructure today. But the goal of the programming language is that, yes, you can go build a web server in Mojo. When Mojo comes to a computer near you, you can use it. You can call into C code, you can call into Python code and weave all the existing technologies and packages together and build a framework for GUIs in Mojo. You can build a web server. It's just like any other programming language. But what the usability of the programming language is limited by what libraries have already been built. And at Modular, it is focused on being for ML applications and for writing kernels and high performance code.
I want to add something, which is we had a blog post in April, I believe, that talked about our performance of matrix multiplication compared to existing high performance libraries like 1DNN, MKL, AMD Compute Library, and so on. But because it was before launch, we'd never mentioned Mojo by name. So this is one thing to know is all that code, all that results were written completely in Mojo without any line of inline assembly, any line of C, C++, whatever. Everything is written. All the kernels that we have internally are written in Mojo. The other thing I want to say is the results that are shown in the blog post are kind of obsolete. We're now like 10% of faster than whatever has been reported. So
but Abdul, for people who haven't written things like matrix multiplication, and we've talked and published some toy examples of this, for example, in the launch video. Why is it hard, right? I mean, have people worked on this problem? I mean, is MKL optimized?
Yeah, so MKL is, in many cases, is a paid product by Intel. It's a paid library, so people pay for it. It's supposed to showcase the Intel hardware. They use, anecdotally, there are some instructions that are being used by MKL that don't exist in the documented standard. And the other thing has been worked on since, for the past 25 years. Right.
This is important. This isn't some random Mandelbrot set or something, some toy example. This is actually super commercially important and to a whole bunch of different people. And so lots of energy has been put into making it go fast.
Yeah, all of HPC, all the clusters, national security clusters and so on depend on MKL and other similar libraries. And MKL is the fastest in that domain. So that's why we compare against them, right? And it's also not a one person, working on it. It's a team of tens or hundreds of people working on it for the past 25 years. PhD theses have been written about matrix multiplication.
Yeah.
So,
Well, so but also this is the wonderful thing about Mojo to me is that it enables pushing the state of the art. And so in machine learning, there are a very small number of people that will do that kind of work, but those people are disproportionately important to what gets invented on this entire technology platform and how the hardware actually gets used, right? But then the cool thing about Mojo is you can take that layer and then go the next layer up, that layer where C++ typically lives. So the kernel performance layer is often assembly written directly for one specific chip. But then Mojo can go up to like what is typically written in C++ and do things like Rust is often used in a safe way, in a beautiful way, in a much more Pythonic way. But then you go up to the application layer, and then you go up to literally the existing Python ecosystem layer that already exists, and you can pull that all together into one stack. And so, I think a big part of what Mojo is about is, yeah, we love Python, we love C++, we love Rust, but none of these solutions can scale and do the whole thing together.
The other thing I would like to highlight is that we've built features into the languages to make it easy to write, a matmul that is competitive with state of the art. But it turns out that these same features are also useful for building a generally productive and useful programming language. It turns out that having powerful metaprogramming is useful for building succinct abstractions and encouraging code reuse and building libraries. It turns out that having direct access to hardware doesn't just make your matrix multiplication faster. It means that you can write faster communication through I/O with direct access to operating system intrinsics or hardware intrinsics for audio decoding. And so all of these features we've built for one use case are generalizable to everything you could do in a programming language.
There are a lot of
yeah, I saw some. I wanted to add one more thing to what Jeff, Abdul, and Chris
No
mentioned. Is like I think there were some questions about AVX and hardware features like that. I think the beauty of Mojo is that you're able to access all of these cool hardware capabilities and hardware blocks that are built for specific AI workloads today, like matrix multiplication units, and so those are all can be expressed within Mojo, and that's the cool thing about having being able to write code that's also, I would say, maybe portable, right? You can access all of these hardware units across different accelerators, right? It gives you that sort of high level language, but still gives you the system access, which is really, really, really the value add for Mojo as a programming language.
I'm barely able to keep up. There are some really, really good questions, and some of them, I guess, segue well to some of the other topics we want to discuss. I suppose I'll bunch many of these questions into one and see if we can take them quickly. There's a comparison to C++, right? And there are two questions in this. One is how do you compare in performance, and secondly, is there an interop with C or C++, or how does that work, or what does that look like, or would look like?
How about I take the generic comparison, then maybe Jeff, you can talk about C interop. But when you look at C++ versus Mojo, this is a question I get asked all the time, often by C++ people, like why bother with Mojo when we already have C++? I mean, my general philosophy on this is that it's not about one thing losing or the other thing winning. It's about appealing and making the world a better place. And so I think objectively we can agree that there are a lot of Python programmers, and what Mojo does is it gives Python superpowers, and it expands and does new things in new ways, and it appeals to new community that C++ is useful for. But if you zero in on compiler nerdery, which we're not going to go too deep in this, like there's a whole bunch of things that are structurally different about the Mojo compiler and toolchain, install experience, packaging, like this entire ecosystem that C++ has never had. And so auto-tuning is a feature that C++ has never had. When you get into machine learning, and this is something that we could talk at the LLVM meeting about or something, right? But a lot of machine learning is about analyzing your code if you write a custom op, and then being able to generate multiple different versions, for example, a shape function or other versions of the kernel that you're writing automatically. And so I'm actually at fault for not solving this problem 20 years ago with Clang, but a lot of the C++ compilers, the way the compiler was designed, the way the language is designed with templates and things like this, don't allow you to implement this higher tech functionality that enables some of the AI use cases that we're building. And so, I mean, you can also get into C++, and I'll complain about C++ because have been dealing with it for so long. But you have both a language and a meta language with templates, and that's kind of unfortunate. Mojo's just has one language that works in both places, and there's a whole bunch of other things like that are, you can argue about whether it's good or bad or whether it matters or something like this. But it comes back to our goals, right? Our goals are to help meet AI programmers where they are, and we're building Mojo because we think it's useful. That doesn't mean that C++ or assembly or any of these other existing technologies are irrelevant or something, right? But we think that it's useful to help bring a new thing into the world.
Yeah, I mean, I personally love C++. It's not going to go away. C++ has its uses in the world, and Mojo also is solving different challenges in C++. But when you talk about how does Mojo and C++ or C work together, well, Mojo is just a compiled language like any other. You can link to static libraries. And so interoperating with C is super easy. You build your Mojo program and you can link it to any C library. You can access the symbols directly. For languages that are perhaps more complicated than C, like C++, where you have name mangling and require a little bit more effort to integrate properly, like have real first-class integration with C++. But if C++, if you want to go through the old C interop in C++ with extern, quote C, then you can call in C++ functions from Mojo quite easily.
There's also a function called external function in the standard library that you can use to call any existing C function, that you've dynamically loaded or you've statically linked. So today you could do C interop.
Awesome. So this question targeted sort of your system programmers, C++ users, right? There's the other audience, which is your Python users, your data science, and I'm going to bundle like 6 or 7 questions that revolve around the same topic. The question is about what does it mean for existing ML libraries like PyTorch and TensorFlow? What does a Mojo, I guess, version of it look like, and what should it look like? I know that was not a question, but I'm trying to bundle like 5 or 6 topics that talk about ML frameworks in the ecosystem of Mojo, or in the land of Mojo.
Pramod, do you want to take this one, or do you want me to take it?
Yeah, I can. So sorry. So Shashank, your meta question was, how does Mojo fit into the land of
Yes.
deep learning frameworks? Okay, so I think one of the other things that we announced at launch was, we're also working on the modular AI engine, right, as a product. So the AI engine is built such that we can interface at different frameworks level. So we can interface with models trained in TensorFlow, PyTorch, you name your framework, and then at the same time, what we're doing is using the Mojo language. We have kernels written in Mojo. The engine can then have portability across different types of hardware, right? So what we're trying to do is we're trying to have seamless interoperability both on the front end as far as frameworks are concerned, as well as on the back end, right? Being able to target different hardware architecture. So Chris is here. It's a classic, the compiler diagram that he drew many years ago in the LLVM textbook. So think of the same sort of analogy, right, as to what we are attempting to build with the Mojo as a programming language, as well as the modular AI engine. Chris, you want to add something?
Well, I mean, I think that this is just such a point of confusion for folks, because the modular engine is really cool. Mojo is really cool. It turns out the modular engine is written in Mojo and it's extensible in Mojo and things like this, but both of these things can be used alone. But we'll be sharing much more about the modular engine and the AI story over time.
The other thing I think we already answered for a different question, which is what about other frameworks and packages on top of Mojo? And I think Jeff shared. You can build this, right? Many of you. I mean, you can build this. You can build this on top of Mojo, right? And the foundation is there, and there's so many different use cases and paths you can take this to, right? Including frameworks.
Yeah. So let me be excited about this. So one of the entire reasons we're allowing you to download Mojo and use it locally on your computer, so you can build cool stuff, right? And so people ask us all the time, are you going to build a GUI library? Are you going to build a Django replacement? Are you going to build this or that or whatever? we're not experts in that. Like, we're working on AI stuff. You all are the experts. You all know these domains. You know what's better and worse in all these different places. And one of the things we'd love to see is smart people building cool stuff in the Mojo community, right? And the language is still young. And so that means that anything you build, you'll have to adapt as the language changes, because we want to make sure that we can make the language really great. We don't want to get stuck into compatibility mode too early. But it also means it's green fields. And there's so much opportunity to build cool stuff out there and share it in different ways. One of the things we're doing to help with that is that we're going to start on the epic trail to open sourcing things soon. Ooh. And so we have to figure out the contribution model. There's a whole bunch of details on this, but we'll be open sourcing probably documentations, library. Like, we have to get started somewhere, and I think our goal is to get that out sometime this year, probably, and get that figured out. That's mostly about figuring out how contributions work and how we want to do all this stuff, how to set boundaries on things, and because we want lots of innovation to happen in the Mojo community, but we don't want it to be all done by Modular, right? Or have to be done by Modular, for sure.
Yeah, I just want to echo.
Please go build all these things when you get the Mojo on your computers. Please go build, GUI. Please go build web servers. Please go build adapters.
Yeah, help us build cool stuff. I mean, that's the whole point of getting the SDK to you guys.
Awesome. Yeah. You want to add something, Pramod, before we move to the next question?
No. I just wanted to say, like, help us build cool stuff.
Yeah,
that's what we're looking for.
I'm going to squash a couple more questions into one while we are on this topic of Python. Few different questions that are asking the same thing, which is, this is about Python interrupt. Is Mojo a strict superset? Will continue to be strict superset? If you have your existing Python code base, can you just bring it in and extend it with Mojo? It's a loaded question, I suppose, but whoever wants to take it.
I'll punt this football over to Jeff. Like, what do you think? What do you think, Jeff?
So there's two angles here. One is that Mojo has first-class interop with Python code, which means that you can call any Python code that already exists, any library from Mojo. So you can call, people have tried to do this in the playground. People have called the TensorFlow Python library from Mojo. You can, the way we displayed the Mandelbrot, pictures in the notebook, and you can create UIs just by calling into the Python libraries. So think about the C interop that we mentioned before. You can call into C code on one side and then call into Python code on the other side. So in that way, Mojo can be seen as just a bridge between these two worlds. But then Mojo also aims to be a superset of Python as a language, as well as living in the Python family. And if you think about what that means, think about C++ versus C. Generally, people consider C++ to be a superset of C. It contains pretty much all the features. There are some very small differences or in the way the standards define particular features. But then C++ built on top of C and added tons of new features, like the void keyword or bool as a first-class data type in a keyword, where it was just a macro in C typically. And then these languages co-evolved over time. A lot of features were backported to C, such as the keywords of void. But C++ and C are not exactly syntactic equivalents. So if you take C code and you move it over to C++, most of it will work the same. Maybe you'll run into some collisions here and there. But the goals of Mojo is that we do intend to be a superset of Python, but Mojo has gone and taken a few extra keywords, right? We've added tons of new features to the language, and building out the feature set of Mojo to be a proper feature superset of Python, it will take a lot of time, because Python has a heavy emphasis on dynamism, duck typing, and generic objects, and untyped arguments and implicit declarations everywhere. And we do want to support all of these over time, so that it is very easy to take existing Python code and run it in Mojo. But for example, Mojo doesn't have a GIL. And so if you're taking Python code that depends on the GIL and take it into Mojo, it's not exactly going to be the same.
The way I understood this, at least when I started using Mojo, is we talk about interop, and we say bringing Python code into Mojo, but there are two different meanings to that, right? One is minimal code changes, and it's actually Mojo code now. It runs as Mojo code. Yes. The other is just run it the way you run Python code, in which case you just import it and run it, and it would use all the Python machinery to run it. So when you say bring Mojo code to Python, there's this two different modes that you'll tease out, and once you start using it, you'll understand. The benefit I found is the stuff that's you can bring into Mojo, you will. The stuff that you can't, or you would just use the interop and still use Python. You don't get speed up there, but you still use it, and you have the entire Python language at your disposal.
Yeah. Well, and oh, sorry, go ahead, Jeff.
One of the stated goals of the language in our roadmap is we want to eventually provide a mechanical translator from Python code to Mojo code. And this is doing like very, very minor things like adding backticks around variables that now collide with keywords in Mojo, and so on and so forth. So that one day you can just bring your Python code into Mojo. A cool feature that exists in the playground right now is you can write a Python function in a Python cell, and then just call that function from a Mojo cell. And so really it feels like this seamless coexistence between the two languages together. And that's one of the experiences we want to provide with the language.
Yeah,
Awesome.
and the goal here is just extreme pragmatism, right? And so the Python community is vast. There's so much useful code. The C community is vast, right? And so being able to directly use C code, Python code directly in your Mojo code, even though Mojo is still a very early language, is super pragmatic and super useful. Now, if you move it to Mojo, then you get more benefits. And somebody asked, can you use Mojo without Python? The answer is yes. Mojo is a standalone language also. And Hello World, that's 20K, doesn't include Python at all, clearly, right? And so being able to subset these things down automatically is super powerful, and it's a really important part of the ecosystem. But anyways, I mean, I think that, again, my experience is people want to like make things very binary, like it has to be this or it has to be that, or somebody has to win or somebody has to lose. You know, our goal is just to put our arms around the industry and say, let's just love each other and get along and build cool things.
There was a question that's related to this, and I don't know if you already answered it. So 20K, right? Hello World. But if you were to use Python in that code and you still build an executable, there was a question here, what happens to the file size, or what are we shipping with this binary now?
So that part will be dynamically linked. So essentially, you include what you use, right? You're not paying for things that you've never used before. If you're using only print, that's what you're paying for. If you'd never used print, your file size will be smaller, etc. So it's include what you use. I mean, one thing I want to mention is, again, the pragmatic nature. We can wait for 5 years and have the perfect language, or we can just say, okay, let's build the community together and then have regular releases where people can, contribute new ideas. They can write kernels or write code that we've never thought about, and just sort of push things to the limits and say, oh, let's file a bug report. And that's a much better progression. If you look at it like 5 years from now, then it is like, oh, let's just solve our own problem and then maybe figure out, imagine other people's problems and solve them. It's much better to just have more engagement, because everybody here has great ideas that, a lot of things, a lot of programs, a lot of bugs that we've never thought about before, and we just need to solve them together rather than, modular just like kind of, put something like, baking for 5 years and then it's like a huge dump.
Well, I mean, just to lean into it a little bit, right? So that's one of the things we talked about when we released or announced Mojo in May, right? Is that instead of announcing it, we could just keep it secret. And one of my previous journeys was with Swift, and Swift was gestated within Apple for 4 years, by a very small group of people before it was like launched onto the world, and it's like, ta-da, here you go, right? But one of the problems that Swift had is that it had no real internal usage. And so it was almost it's not fair to say, but it's almost like building a thing for somebody else without asking them what they want, right? And so with Mojo, what we're doing is we're learning from that and being much more open. And so we still want to be able to build the right thing. We have very big ambitions. It'll take, a little bit of time to build this stuff out, but we think it's much better to share with the community and get feedback and co-develop this, even though it means that, Mojo with the SDK launch will be a 0.2 language. but doing that openly and evolving towards 1.0 together, I think, is a much better way to go than just like having the cloistered monks on the hill go off and like come up with some new ideas and then hand down the tablets later. So
Thank you for all the questions. There are so many questions coming in. I know we won't be able to get to all of these today, so I'm trying to focus on the ones that are higher level. There are very, very specific technical questions here too, which we'll try to get to, but I want to focus on some of the higher level questions here. This one, I'll squash again a couple of different questions. This is about GPU support. Does Mojo support GPU? And the other is, what is the role of Mojo in the ecosystem of CUDA, OpenAI, Triton, Numba, other tools that are used to accelerate on accelerators, specifically GPU?
yeah, Pramod, do you want to take this, or do you want me to take? I know I hear you know a thing or two about GPUs.
Why don't you go, Chris, and then I'll add some of my thoughts as well.
Yeah, well, so again, this is something that's super confusing often because there's a difference between the language and its capabilities. And so people ask about WASM, they ask about like many of these other things, they ask about GPUs and stuff like this. So I can objectively say, yes, you can compile for GPUs with Mojo, or we can compile for GPUs with Mojo, and we do that. But just generating a blob of PTX, which is the low-level thing that you upload to a GPU, is itself not super useful. It's like it's an ingredient. It's not a cake. And so the thing you actually want there is you want an AI engine, or you want something where you can handle the communication that happens on the host CPU. The fact that you don't have one GPU these days, you often have many GPUs. You often have many machines that are communicating over high performance, fancy networking with exotic interconnects and all this kind of stuff. And so like that bigger systems problem is the domain of the AI engine. And so, yes, Mojo can do some of this stuff, and we'll be announcing and talking about some of that more later. But really what you need there is it's not just a programming language. You need a higher level system that can drive this much more heterogeneous compute thing that AI has become these days.
Yeah, I also want to add that, when you talked about, Shashank, when you asked about, CUDA or OpenAI, Triton, I just wanted to say that, Mojo, what we have built is, to my previous point, Mojo is a real programming language, and what we are attempting to do is, give a Python-like syntax, but also be able to express all of the hardware capabilities that you can do. So if you are able to, use simile or vectors and express matrix multiplication, then those get automatically not all, but those get translated to the required, whether that's PTX or GCN for AMD or whatever GPU intermediate representation you have. Those just get translated by the compiler, right? And we are able to generate device code for different types of accelerators, right? But using a more higher level language, that's Mojo closer to Python.
Yeah.
The other thing is, for any high-level languages, you need an escape hatch for performance, or you need and that's like a corner case where you absolutely need like the ugliness of internal details, and that's something that Mojo provides. Actually, Mojo is a wrapper around, or in some cases you can think of it as syntax trigger around MLAR. So it actually allows you to have all the features of MLAR, all the features of LLVM, which means 20 years of work, 20-year history of like many thousands of people, pouring their brains out into the code base. So you can tap into all that access, and you don't really need a compiler for that. You can access that directly from the language.
Yeah. I mean, one additional thought I'll give y'all out there that care about this stuff is that, so I helped build OpenCL back at Apple, right? And things like this. And some really smart people built CUDA in the NVIDIA world. And there's many of these other languages and things. There's Triton, these things. The way that all of these projects, including, for example, OpenCL, worked is they said, okay, I want to solve for an accelerator. Let me see what language I have off the shelf that I can just grab, because I want to solve the accelerator problem. I don't want to solve the programming model for accelerators problem, right? And so I think Mojo, at least at scale, there's probably research projects, but it's probably the first at scale approach where he said, let's take all of the best in class knowledge about how to design programming languages. Let's take all of this knowledge about all the different weird kinds of accelerators and ASICs and things like this and build something that's really good for solving this AI problem, which is inherently about exploiting the full power of these crazy accelerators, right? And so this is one of the areas where you look at Triton. Triton's not a language. It's what's called an embedded DSL. So it doesn't have a debugger. It works within Python, but it's, you know, it's cool, but it's not as flexible, right? And there's lots of challenges like that. And so Mojo is a much more ambitious project in many ways than a lot of these projects have been historically.
Yeah, it's interesting. It's something like Triton. I think it was invented to solve that problem, right? Like PyTorch, for example, compile, generates Triton code. If it didn't have to, it wouldn't have. it needs a path out, and Triton's filling that void there, so to say. And as a someone from a scientific computing sort of background, not systems programmer, right? There's this dual language problem we spoke about, like using Python, but when you want performance, you need the backdoor hatch that Abdul mentioned, which is, okay, now I'll go write all of this in C++. Or
yeah. Well, so the other thing about this, like, I mean, let's not forget, like, this stuff is really hard. Designing a programming language, for example, Promote was demoing not just a compiler, but a full tool chain, which includes IDE support, code formatting, debugger, REPL. Like, this is really hard. This is a lot of work, and it takes a really committed team with a bunch of experience. And so what Modular is doing is we're leaning into this problem. We know it's hard. We've done this before. We want to do it the right way. And so you can see the way we approach this problem is it's not our first rodeo. We want to do it. We've learned a few things, and so we want to do it the right way for the next 10 years, 15 years, 20 years, 30 years, because where today we have CPUs and GPUs and AI, and it's exciting and it's kind of a hot mess, and like all the different problems people are struggling with. If you look at what's happening with hardware, there's going to be more weird hardware, more ASICs, more heterogeneous stuff. Like, this is going to be the continuation into the future. And we want to make sure that Mojo and all the other technologies that we're building are prepared for that. And so far, we haven't seen a lot of approaches that try to take that holistic approach. And, you know, though it's super hard, which is why it takes, you know, a few months to build things. And we have a really good team, fortunately, but it does take time to roll these things out. But this is why you'll see us take very deliberate steps. And you may be frustrated because we're moving, quote unquote, so slow. But actually, if you take a look at how hard these problems are, we're moving blisteringly fast. So
awesome. Again, I'll pivot a little bit more to like language feature-based questions. We'll get a little more, I guess, specific. And I'm going to squash a few different questions here. They're all about debugging. The question is, does Mojo support debugging with LLDB or GDB? And a related question is, how does debugging work when you're using Python interop?
Python interop is an interesting question, but I did see someone ask, how do you debug, you know, C code linked into Mojo code, for example? That just works. Mojo has support for generating debug info like -G with GCC. And then if you can build a Mojo static, you know, binary with debug info, you link into a C binary with debug info. It just generates a binary like C or C++. You can run this binary in LLDB or GDB, and if you get a crash, right? Let's say you get the crash in your C code, right? If that C code was built with debug info, you will see a full stack trace going from the Mojo calls into the C code, even back into Mojo if you're, you know, calling Mojo from C and C from Mojo. So we do intend to provide debugging support. We can build code with debug info, and if other code also has debug info, then it will all, you know, meld together, because that's just how we link. That's just how Mojo code's linked with C code. The Python story is a bit more interesting because debugging in Python is not the same as debugging in like a compiled language. In a compiled language, you have the debugger will run the code in an inferior process and like stop it. And if it crashes, it can detect when it crashes, and you get a backtrace with all this information. But Python itself has stack traces when an an exception gets thrown. And many people on right now who've noticed in the playground trying to call Python that when Python throws an error, the message that comes out of Mojo is not very great. But that's something that we really want to improve going forward.
Awesome. All right. A few other quick questions. The question about hardware support. Does Mojo work on your usual suspects, I suppose, like Intel, ARM? Anything we want to share at this moment about all the different hardware you could run Mojo on?
Yeah, I can take that. So when we are going to Meta Story, yes, we support various types of hardware. The Mojo is a language, and internally we have support for ARM, for x86, different types of CPUs. But when the SDK is released, off the bat, we're going to support only the Linux operating system on the x86 CPU architecture, and then we're going to quickly follow up that with support for Windows and Mac coming soon in the next few weeks. So I would say we're trying to accelerate the roadmap as fast as possible, but the very first release will only be supported on Linux x86.
Now at this point, I'm going to say go sign up on the webpage to be notified and join the Discord channel. Thank you for seeding us that question for that call to action.
Well, and one of the other things I'd say is that Mojo has a lot of raw potential. I mean, somebody's very excited about embedded microcontrollers, apparently, for example. And so Mojo can totally do that, but there's a difference of what we want to invest in and focus on and productize. And so the thing to know about Mojo is it's not a research project, right? We're actively using this thing. This is a key part of the modular engine, and it's really important to build things as a production quality thing so that you can build on top of and do cool research on top of, instead of the thing itself being research. And so this is where with Mac, for example, many of us live on Macs and stuff like this, but we want to make sure to do full release validation and get all that infrastructure in place so that we make sure that we're always shipping very high quality things.
Awesome.
I will qualify something, which is you can use Mojo SDK and WSL Linux. So on Windows you can install WSL and use Mojo. On Mac, kind of similar to what Pramod was showing in his demo, you can do a remote connection to another Linux machine. So you can have the IDE locally, but connecting to a remote system or a container on your local system. So,
well, one of the ways people are going to come into Mojo is through other languages. I mean, we spoke about Python users today. Python users, it's the closest thing you can find. The system programmers who come in from C++. There's another language that's come up a couple of times, which is Rust. Do we want to talk about comparison to Rust, or what a Rust developer would need to know, or what the migration path might look like, or interop, so to say, with Rust?
I don't think we don't have any plans for an interop story with Rust or something like that. And honestly, I don't think we're focused on, just in terms of all the different problems we have, I don't think our focus is to make it easy for a Rust programmer to learn Mojo. But that said, Rust is a major influence. And so Rust has so many good ideas with the lifetimes approach, and it's a modern language and has a bunch of really good ideas. And so I think that what you'll see in Mojo is that, we're not trying to make Mojo any other existing language, but we're very happy to learn from the best ideas that come from all the languages. And so Rust and Swift and Julia, we get asked about all the time. Like, all these languages are wonderful languages. Even C++ has some good things about it, right? And so we're very happy to learn from all these languages and incorporate the best ideas into Mojo. But really, a lot of our North Star is meet Python developers where they are. And so all these other existing languages have really good ideas, they're cool, but they don't help a Python programmer grow. They always require a Python programmer to reset into a different skill set and start from scratch. And so because of that, what we'll do is we'll focus on making the best thing we can that solves the problems of scaling top to bottom across the entire software stack and be super Pythonic and help lift the industry from that perspective.
Yeah, in terms of easing in programmers from other languages, the main one is, of course, Python. Right? We're here to meet Python programmers where they are, which is in Python. And part of that is ensuring that the language in general feels familiar. It doesn't feel alien or new. You feel like you can do the same things you can in Python. But also, Mojo adds tons of new features. And of course, learning this from the perspective of a Python programmer can be difficult, which is why that Mojo specifically is going to provide a tutorial, sort of a course of how, as a Python programmer, you can ease into the Mojo world and learn some of these features from the perspective of being a Python programmer, rather than coming from a systems programming background where one may be more familiar with the concept of like destructors and lifetimes.
Awesome. So many other questions here. Now we're getting into sort of feature specific, language specific feature questions. I'll maybe we can go through this more quickly as we have about 5 minutes left. Any ideas on Mojo and Python async, wait, interop, and interaction? Was that a complete question? I don't know. Anyone want to take that?
Jeff?
Well, Mojo has async functions. Async functions are the way we build parallel code in Mojo, true parallel code. Async in Python is interesting because Python doesn't have true parallelism within the same interpreter instance due to the global interpreter log. Async in Python is primarily used for I/O related tasks, where functions may wait on hard drive reading or a web server request rather than other Python code. But in Mojo, we've extended this model because we don't have a GIL, so that you can write true async code and then parallelize it through a runtime. So you can give multiple instances of an async function to a thread queue. And then that thread pool will run tasks at the same time. You can collect the results, a fork join pattern. And in terms of interoping between Python async functions and Mojo async functions, I think that's an interesting question because they're sort of different things. And I think that's something to look at in terms of the Python interop story.
Okay. We'll move to the next one then. We have a couple more minutes left. Will we be able to use MLIR dialects beyond index, LLVM, POP in Mojo?
There's like a ton of questions about compiler architecture, and several of us on this, I think, literally, yeah. So Pramoda's a compiler engineer, Abdul's a compiler engineer, Jeff's a compiler engineer. I studied compilers in school back in the day. We're very fortunate. We're going to be giving the keynote at the LLVM developer meeting. And so we'll be talking a lot about the architecture and the design of the Mojo compiler. And so, one hint I'll tell you if you're an MLIR fan is that MLIR, we figured out, actually stands for Mojo Language IR. and so we'll be talking all about that at the LLVM meeting. And so hope to talk all about that then.
Yeah.
I mean, I love hacking on compilers personally. I think we all do. And part of the experience that we want to provide with Mojo is the ability to really hack into the compiler. But that is an experience that will get built out more over time. And after all, hacking into the compiler, hacking directly on the hardware is how we get performance. Is how we get all these cool features.
Awesome. Yeah. So be sure to check out the keynote if you're into that. If you're from that world of
a compiler nerd. Yeah.
Compiler
meeting. Yes.
Yeah. We love compiler nerds, but
okay. This is a very important one. I'm gonna ask this with a very serious face. Are there any Easter eggs in the Mojo SDK?
I don't know. Are there?
I think you should all try to find it and let us know, right?
Or provide good suggestions on what Easter eggs should be included.
I will tell you a secret. There are some Easter eggs on the website when the website will be open. So find those when you get access to it.
Yeah, and let us know on the Discord channel. So please join the Discord community and share. We have a bunch of fun people there sharing, helping each other. So that's where you share. This is an interesting question too. Does Modular plan to hire engineers remotely or from various time zones? Are we hiring? Jeff, Chris, Pramod?
I can take this one. Yes, we're very fortunate that we're growing. We're hiring. We're looking for very specialized skill sets. We generally hire out of US flavored time zones, plus or minus, depending. But we do make exceptions in Europe. And so we're expanding. And if you are interested, please check out our career page, because we have a bunch of jobs posted there, and we're growing. And they're often very low-level kind of hardware, software boundary, ML specialized kind of roles, but we do have other positions as well. And the careers page is always the best place to check that out.
Awesome. We
So
are actually
one
ahead.
final request from the bottom of my heart. Please, when the Mojo goes out to the world, when you see bugs, we have a GitHub repo. It's github.com/modularml/mojo. Please file bugs if you see them.
Yes.
Yeah, and also please file ideas, right, and upvote ideas on the GitHub website. So we're also looking for, we want to build out the roadmap. So, your ideas and upvotes will be very helpful in prioritizing what we should be building. So
Yeah.
And even GitHub stars are cool too.
yeah, GitHub
Oh, yeah.
stars are cool. Yes, star our GitHub repository.
Yeah, all those questions about is there a framework for this and that, I think those are all good stuff to share as issues and let us know. I mean, that's how we prioritize stuff. Okay, we are at time. There were so many questions. I know we couldn't get to all of them. We probably won't get to all of them if we stayed here all day, which I know Jeff, Abdul, Chris, and Pramod would like to do it. But we do have to wrap up. But the good news is we'll do many more of these. We do have one scheduled, or we'll be scheduling soon, the one post launch. So at some point when we have the Mojo SDK available and you've had a chance to play with it, we will schedule one after that. So that live stream will be focused on questions that we can answer about the SDK itself. So be on a lookout for that. And the way you can do that is to sign up again on our website and also follow us on social channels if you're into that sort of thing. Other quick things. This stuff is exciting, and you're not already on our Discord. Please join, and we'll be posting. We'll be sharing a lot of information there, and that's about it. Any last comments or stuff to share?
No. Well, thank you for keeping us on track, Shashank. I think this is really great.
Yeah. All right. So we'll wrap up here, and stay tuned. Follow us on our LinkedIn and YouTube too, so you'll be notified when we have new videos or other live streams. So with that, we'll close. Thanks again, everyone. See you soon.
Everyone.
Yeah, thank you guys. Bye.